Your body is running ancient survival code you never agreed to install. Some of it saves your life before you think, and some of it can drop you unconscious at the sight of blood. But the strangest part is that one instinct may be watching you back.
The Moro reflex. A baby can look startled before it has a single word for danger. The Moro reflex is your first falling alarm, present from birth in term infants, named by Austrian pediatrician Ernst Moro in 1918, and still tested during newborn exams today. A sudden loss of support, a loud sound, a falling sensation, or a hard vestibular jolt flips the circuit. Both arms shoot outward, fingers spread. Then the arms fold back inward, as if trying to clutch a vanished ledge, and crying often follows. Fetuses can show this response from around 28 weeks of gestation, and most babies lose it by about 4 to 6 months. If the reflex fires unevenly, or lingers too long, clinicians flag injury or neurological trouble. Panic comes online before memory. Contagious yawning. After fear primes your body, a quieter circuit takes over. Someone yawns across the room, and seconds later, your face obeys a signal your lungs never sent. Your jaw drops, your eyes narrow. Your brainstem runs the old vertebrate pattern. Deep inhale, facial stretch, brief eye closure, exhale. Usually for 4 to 7 seconds. But the trigger can be social, not physical. You can catch it from a sound, a sentence, or just the idea of yawning. Robert Provine showed how yawns behave like stimulus-driven actions. Later, Stephen Plattek linked contagious yawning with empathy and self-processing networks. In lab video studies, about 40 to 60% of adults follow the cue. Your body is not tired, it is sinking. Piloerection. Goosebumps. A cold gust hits, a sound cracks behind you, and your forearm answers before you do. That is piloerection. Your sympathetic nervous system fires adrenergic signals into tiny erector pili muscles, which contract and yank each hair shaft upright in seconds. In a furred mammal, that raised coat traps insulating air or makes the body look larger, a heat shield that can double as a threat display. Darwin pinned this reaction to emotional expression in The Expression of the Emotions in Man and Animals in 1872. In humans, cold, fear, awe, and music still trigger the same sympathetic spike. Jaak Panksepp linked music chills, or frisson, to this response in 1995. Your skin becomes a live map of survival math. Next, light hits the eye, and the body moves first. The pupillary light reflex. The penlight hits your eye, and within about 200 milliseconds, your pupil snaps smaller. That is the pupillary light reflex, your built-in shutter against overload. Light lands on the retina. The signal runs through the optic nerve to the midbrain, then back through the oculomotor nerve to the iris sphincter muscle. You do not choose it. Your eye does. The constriction cuts light exposure and helps keep photoreceptors from bleaching under a blast of brightness. In the ER, that tiny black circle becomes a fast brain check after head trauma, overdose, or cardiac arrest. PERRL means pupils equal, round, reactive to light. If one stays fixed and wide after head injury, think third nerve compression from transtentorial herniation. Tiny opening, big warning. The gag reflex. Press the back of your throat and your body slams the door. Your palate lifts, your pharynx clamps down. Your head jerks back and you cough, retch, or even vomit before your conscious brain gets a vote. Your doctor calls this the pharyngeal reflex, but you know it as the gag reflex. Its trigger map covers the posterior pharynx, soft palate, tonsillar area, and base of the tongue, the last checkpoint before trouble enters your airway or upper digestive tract. Sensory alarms run mainly through cranial nerve 9. Motor orders return through cranial nerve 10. The medulla conducts the whole reflex. Sherrington helped explain that logic. Fast circuits beat slow decisions, and this one protects the entrance. The pain withdrawal reflex. Touch a hot stove and your finger vanishes before your brain files the complaint. That is the pain withdrawal reflex, a spinal protective circuit that can complete its arc in roughly 50 to 130 milliseconds. Painful heat, sharp pressure, electric shock, or tissue damage fires A delta and C fibers from the skin into your spinal cord. The faster A delta fibers can conduct at about 5 to 30 meters per second, fast enough for local spinal wiring to seize control. Interneurons switch on motor neurons. Your flexor muscles contract, and the limb pulls away. Your cortex can trail the movement by up to 300 milliseconds. Pain doubles as a motor command, firing escape before awareness even enters the room. The mammalian dive reflex. Now the instincts get stranger, starting with your face. Dunk it in cold water, especially across your forehead and nose, and trigeminal afferents fire into brainstem cardiovascular centers, including the nucleus tractus solitarius. Your vagus nerve clamps down on the heart. In many adults, heart rate drops by roughly 10 to 30%. Sympathetic output tightens vessels in your limbs. Blood drains from your fingers, your hands blanch, and oxygen gets routed toward the organs that matter most, your brain and heart. Cold water hits harder than warm water, and the face beats hands or feet because the trigeminal circuit is wired for this. Paul Bert mapped the roots in the 1870s. Per Scholander named the master switch in 1963. In elite freedivers, the pulse drops below 30 beats per minute. Conservation becomes command. Vasovagal syncope at blood or injury cues. Your strangest threat response makes you worse at surviving the obvious threat. Blood, needles, wounds, or injury cues can trigger vasovagal syncope, a circuit that starts like alarm and ends like shutdown. First, your sympathetic system surges. Then, the brake slams down. Parasympathetic dominance rises. Blood vessels relax, heart rate slows, blood pressure drops, and cerebral perfusion falls. Your brain loses the pressure it needs to keep you upright. Pallor shows as circulation shifts. Sweat breaks. Your eyes unfocus. You sway, your knees fold, and the floor becomes the backup plan. In 1961, Graham, Kabler, and Lunsford described this fainting pattern in blood injury phobia. Applied tension fights it by squeezing large muscles and forcing pressure back up. Collapse can be a crude anti-bleeding strategy. Weird circuit. Real survival math. The freeze response. But when escape math fails, your brain can hit a deeper switch. Tonic immobility. A startle signal races through the brainstem. Your periaqueductal gray takes command, and the dorsal vagal complex slams on the brake. Heart rate can plunge by about 30% in under a second. Breathing stalls. Your gaze locks. Movement drops to near zero. That is not surrender. It is concealment with a pulse. In prey studies, motion is the giveaway, and immobility can cut detection by ambush predators by more than half. Humans report the same lock during assaults and disasters, often with dissociation layered on top. Shame comes later, from a conscious brain judging an automatic circuit. Your body chose stillness because stillness can buy one more second. Sleep pressure. But what if the circuit does not freeze you in place? It slowly turns your waking brain down while you are still trying to use it. This is your body's accumulating demand for sleep, driven in part by adenosine, a byproduct of cellular energy use that builds up in the brain during wakefulness. Alexander Borby's 1982 model split sleep control into process S, this rising pressure, and process C, your circadian clock. By 1997, Porkka Heiskanen and colleagues showed extracellular adenosine rising during prolonged wakefulness in the basal forebrain. After 16 to 18 hours awake, attention and reaction time degrade. Around 24 hours, some tasks can resemble a blood alcohol concentration near 0.10%. Caffeine blocks adenosine receptors for 3 to 7 hours. It hides the debt. It does not pay it. And next, the brain stops protecting you and starts protecting something smaller. The baby schema caregiving response. From that unpaid sleep debt, Konrad Lorenz raised the stakes in 1943 when he argued that a baby's face can switch on an adult like a key in a lock. He called the pattern Kindchen schema, or baby schema, an innate releasing mechanism for caregiving. Large eyes, a round face, a high forehead, a small nose, and a small chin grab your attention before you choose to be charmed. In the 2000s, Morton Kringelbach, Alan Stein, and colleagues used neuroimaging to show rapid reward and attention responses to infant faces, with some MEG studies pointing to orbitofrontal processing within about 130 milliseconds. In 2009, Melanie Glocker's team intensified those features, and people rated the faces cuter, with stronger motivation to care. Your voice softens, you lean in, and next, the same machinery starts finding meaning where there may be none. Pareidolia. Your eyes hit a shadowed window, and your brain starts hunting for a watcher. That is pareidolia. You pull meaning, especially faces, out of random noise because your fusiform face area is tuned for faces fast. So your burnt toast grows two dark eyes. A wall stain becomes a hunched figure. Grainy security footage turns one shifting shadow into a person. NASA's Viking 1 orbiter photographed the famous face on Mars in 1976, and your species did what it does best. It saw a face before it saw geology. The survival math is harsh. Mistake a bush for a watcher, and you waste a heartbeat. Miss a watcher in the bush, and you may not get another. Pareidolia is your danger scanner, and darkness gives it teeth.